That's cool. Got it. I'll change that. And yeah, Kira, you do the PowerPoint. That's wonderful. And I'll do the
Cool.
inference this week. I might have to get a hold of you guys for some help, but we'll figure it out.
Okay.
I don't know how much help I can be. PowerPoint's just like insert data here, insert information. I'm really good at that, guys.
Okay, cool. For one of my classes, we have to do a presentation. Have you ever used Prezi instead of PowerPoint?
No.
It's interesting. It's kind of PowerPointy, but I don't know.
Different. I never have to. It's awful.
Yeah, different.
I don't know. I don't like switching up things. So, like, if it's something new, I'm not very excited about it.
Yeah, it's all new, and we had you're supposed to put music to it. I'm like, oh my gosh, anymore? I can't even play music, for crying out loud, with all these. We still have a turntable, and I use that sucker. So, Boy.
That's awesome.
All right. Shall we do the quiz?
Let's go for it.
I gotta find it.
So we have the test in this class next week?
Yeah.
But I think it opens up this week.
Oh, really?
I think. I could be wrong.
No, it opens up the 15th, I think. It's either the 15th or the 16th.
Okay, so that's this week because next Monday's the 18th.
Wow.
Because it's my birthday.
Happy
That's
birthday.
awesome.
Yeah, thanks.
Huh.
29 and holding. All right, so we all get the first two right. I know.
Let's see.
Hey, Dad.
So ice cream down on the freezer with buttercrunch.
Thank you.
Yeah.
I can.
You have buttercrunch?
Yes.
So I believe it's the third one down for question number 3.
Yeah, that looks right.
I'm still pulling up the quiz, but
Oh, okay. Well, we'll wait for you.
okay.
I'm sorry.
Because I know it's likely I could have to use it, and then it takes me longer. Okay, it's up. So which one did you say the third one was?
The third one.
Oh, okay.
Third one down.
Yeah.
Equals
Gotcha.
and
Greater than not equals 0, and then not 0.
all right. Difference between the observed.
It's the difference between the observed value of y and the value that would have been predicted by the regression line. So that's the third one down. Right?
Yeah.
Wait, what's the question?
A residual
Yes.
is,
Okay.
I
And
put
which one
this,
did you say?
it's the third one. It's the difference between the observed value y and the value predicted by the regression line.
Okay. Oh, and are we
Yeah.
recording?
Yeah.
Yeah.
Okay, sweet.
Thanks for reminding me.
No problem. Plot of residuals.
Just thought I'd check, but yeah, we are.
Sweet.
Okay.
Residual supports using linear regression when?
Well, megaphone is not what you want.
Huh.
And they don't have to be.
All right. Residuals. Feed. All right, it's not the one with the pattern.
And it's not the megaphone. I think it's the first one.
Yeah.
That makes sense.
Random scatter. There's no obvious pattern. All right. So.
All right.
Which one?
Can somebody get into math self, or do you want me to?
I have the math one. I don't have the crocodile one.
Okay. So, are you in SPSS?
No, I'm in Excel, but I figured out what I did wrong last time.
Okay.
So.
Do you want me to
What
read you
are
the
we trying? Which one is supposed to be Y and which one is X, do you think?
Well, like, Y is the respondent variable, or in, I know in SPSS you put that in the dependent box. Oh, okay, so you're asking which one should be?
Yeah,
Y?
which one is X and Y?
I don't have the data up.
Alright, well there's score and then there's confidence rating mean. I think its score is X. And Y is the confidence rating mean.
That's the response variable in the dependent.
Yeah.
Oh, wait, no, X is the explanatory, sorry.
Yeah.
Okay.
Alright, go to this one. Paste. Alright. Insert tab and scatter. Sorry, I'm just trying to. Okay. So, the residuals.
So the answers are, the residuals are between -40 and 25. The residuals form a linear pattern. The residuals are all negative.
Negative. And they do not form a linear pattern, but they are between
-40 and 25.
I think so. I don't really understand what this graph is telling me. Right now, it just made the scatter plot graph. But everything is positive.
Everything is what?
Everything's positive. It doesn't.
So it would be the first one because you said they do not form a linear pattern?
They don't.
Okay.
Right.
And then do you have the QQ plot up?
Yeah.
So are the residuals are clearly not normal or look right skewed?
In mine, they look normal.
Okay, fairly normal.
Okay.
Yeah.
And then we need to use the scatter plot, the residual plot, and the QQ plot and see which of the 5 assumptions about linear regression are satisfied.
Have a scatter plot.
So on the scatter plot, does it look like a hot dog? The one that's, you know, it looks like a hot dog with a bun around it.
Yes.
So that's the first one. And then the error term, so that E, which I can never epsilon or whatever, is normally distributed. Does that look normally distributed?
I don't really understand this little. I'm so sorry, guys.
Do you see it, Ryan?
I'm not really 100% sure what to look for when it says the variance of the error term.
Yeah.
Well, this is oh, okay.
I really don't know what I'm supposed to be looking for.
Well, the variance, like the x-axis, are they pretty much all along there, or are there outliers? Wait, kind of far outliers.
I mean, are they all close to the x-axis, or are they?
Are they all like in a line? They're not all over the place, I guess.
Well, I have 2 graphs here. I have one for the residuals, and then I have the one for the explanatory and the response variable. And on the explanatory and response variable, they're all in kind of a line. They're just not, they're all over the
I thought you said the scatter plot looked like a hot dog.
One of them looks like a hot dog. The other one looks like a bunch of mess.
Okay. So long as the bunch of mess doesn't look like a megaphone.
I don't think so.
Okay.
Here, show you it. I really am like completely lost.
Well, I'm really lost too. But we can do this together.
So these are the two graphs that I have. This is the one that it gives me based off the information that I put in. And then this is the scatter plot.
Did we lose you, Kira?
I'm right here.
Oh, okay. I only see a still picture.
Um, okay, do you guys can you hear me? See me?
Ouch, I can hear you. Yep.
Okay. I'm sorry, I was reading the information on the textbook. So the scatter plot does not show a pattern, so they're normally distributed.
Okay, so the residual plot, there's no pattern in the residual, correct?
Mm-hmm.
And we've got the hot dog.
Yeah.
The QQ plot, if the points in the QQ plot are close to the line, then that's met.
I don't know how to make a Q plot.
I didn't do it on
A what plot?
QQ plot. You know how to do that in SPSS?
Yeah, so I have the it says the normal QQ plot of the confidence rating mean, and then the next one says the detrended normal QQ plot of the confidence rating mean, and they both look fairly different.
So is the normal one, are the QQ plots close to the line?
Yeah, they're fairly close, yeah.
Okay, so that means the third one is met. So right now we've got 1, 2, and 3 met.
Okay.
And then the x are known constants. X should be measured accurately and precisely. It cannot be checked directly. And observations and independent says they cannot be checked directly. Knowing the value of one of the y's tells you nothing about any other point. So those last two I don't have a good understanding of. Do you think we should just hit all 5? I don't know, because it says you can't. Like I said, I don't have a good understanding of the last two.
Observations are independent. They look they're independent.
Okay.
And I think they all measured without error because they're all showing up.
Okay.
Wait, does it say there's no const, like there's not the same number in the x's?
It just says they cannot be checked directly. X's should be measured accurately and precisely. That's what you hope to see.
I think they are.
Okay. All right. So we would mark all 5.
Mm-hmm.
Do you know what the beta 1, where the estimate for the slope is?
I got 0.042. What did you get, Ryan?
What does the slope look like?
Positive. Exactly. Well, I guess this way for you guys.
In the coefficient box.
Was in the coefficient box?
Yep. The slope is
well, if it's in the coefficient box, then it is 0.003.
Well, that's what it is in SPSS. The slope is the second number. The first number is y. The second is the x, which is the slope.
Yeah.
Okay. So now construct a 95% confidence interval for beta 1. We have to have the lower and the upper bound. Do you know how to do that in Excel?
I'm looking at it. Wait. No. Confidence intervals.
Where do you get the? I only see the SPSS directions, so.
It's right above. So there's the SPSS box in the textbook, and there's the. All right.
Okay, so.
Do you know how to do it in SPSS, Beth?
Yep.
How do you do that?
Linear regression.
Go to analyze, regression, and linear.
Mm-hmm.
Put your response variable, your y variable in the dependent box, and your x in the independent box.
Yeah.
And then statistics.
Uh-huh.
Confidence level.
Uh-huh.
Correlation.
Where's correlation at? Part and partial correlations?
Yes.
Oh, I got it.
Okay.
And then continue and save. All right, so what's the lower bound?
Well, okay, I have 4 numbers.
Oh.
It says the confidence interval for slope. Okay, wait. Do we want the confidence interval for slope or for? Oh, for B1, so slope.
We want it
All
for
right.
B,
The lower.
or beta 1.
All right. So for slope, it is 0.035.
Okay.
And
then we
upper
need
bound is 0.048.
okay.
And I think the slope is, yeah, the slope. Based on the evidence and use the level of significance, what decision could you make regarding? All right.
Yep, so B1 is the slope. Yep. So we're good. Okay. And then based on the evidence and using the level significance of 0.05, what decision would you make regarding the hypothesis test for B1? So it's 0.003 and 0.035 is not between 1. I mean, there's no 1 in there.
Yeah. This really fast.
So this is what confuses me. Are we rejecting the null or not?
It is smaller. You
So the
reject.
p-value is less than the level of significance? Okay.
Yes.
So if we reject it, we have sufficient evidence to state. So.
Yeah, I think the third one.
Yeah. Okay. Gotcha.
Mm-hmm.
Also, I think question 9 is 0.042.
Okay.
What I was trying to figure out, just off the examples they give in the textbook. That's what it is. All right.
And then question 13.
Null hypothesis, what does it mean? Does that mean there's sufficient evidence to conclude?
There is sufficient evidence to conclude.
What are we trying to conclude?
And then you state the alternative in plain English. So that would be the last one.
Yeah. I don't have the crocodile one. I couldn't find it.
Okay, I just clicked on it.
It's a lot further back than it normally is.
I don't know which one is the dependent. The dependent would be.
I believe.
I gotta go back to the.
I believe it'd be body length, wouldn't it?
That's what I put. Because
what did you say?
The head length was used to predict the body length.
Then wouldn't the body length be the dependent variable?
That's what we put. Yeah.
Oh.
Guess what? That's exactly there. I've got an example further back last week, and it's the body length because this is what we are predicting based on the head length. So that's the y variable.
Oh, awesome.
Yep.
All right.
Okay, can you do a 95% confidence interval for B1? For beta 1? Ryan?
I'm gonna try.
All right.
So I'd go to Analyze, and then
Regression and then linear.
uh-huh.
And we're getting residuals and confidence interval. Then you put the response variable in the dependent box. So you put the head length in the, I'm so sorry. Put the body length in there.
And the dependent, and the length.
And then the independent one is the head length.
Yeah.
Yep.
It shows
then,
2 head lengths, but that's kind of weird.
Hmm.
Oh, I think it's just one. It just didn't transfer over.
And then statistics.
Confidence interval. Is that all I would need?
Confidence level. I have correlation, continue, and save.
Okay. And then save that.
Oh, the first thing we need to determine, is the margin of error.
How would we find that?
Do you see something there that has an M by it for the margin of error?
Let me check. An M, you said?
Well, that was just a guess because I don't have anything written down for the margin of error. I don't have anything.
Yeah.
Yeah, like there's nothing about it in the textbook. I've been looking for it. What?
What?
It just doesn't say anything.
I have the standard error of the estimate, but I don't know if that's the margin of error.
Well, let's just put that in.
Okay. It's 10.801.
All right. And what's the lower bound?
The lower
for
bound.
B1.
Let's see. So there's one, the very first one says constant, and then the second lower bound says head length in centimeters.
I
So
think
just want the bottom.
I think I remember that we used the constant.
Okay. Then the lower bound is negative 38.760.
And the upper?
2.212. That's of the constant.
So based on your lower bound and upper bound from the two proportions, what can we say about beta 1? I don't know. Well, there's one
So
in
it should stay with the
between.
What does it say the p-value is?
So the says sigma in coefficients is 0.078 for the constant. And the head length is 0.000. So if we want to do the constant again, then it'd be 0.078.
What would that mean?
I was just trying to think.
I think that means that you would fail to reject the null.
Well, the answers are we are 95% confident the confidence interval will contain the true value of B1. There is a 95% chance the confidence interval will contain the true value of B1, beta 1, which is a slope. And there is insufficient evidence to reject the null hypothesis.
Huh. If I were to guess, I'd say the third one, but what do you guys think? I'm not 100% sure.
I can't even guess. I don't know.
I can
What'd you say?
see the data. That's good enough. You think it is that I.
All right. So shall we submit this puppy?
Yep.
So
We got the first two right.
woo!
Okay, we missed 8, 9, 10, 11,
Oh my gosh.
15, 16, 17, crap, 66.67.
Oh my gosh.
Awesome.
Wow.